Hey everybody, my name is Bryce Wilson, and welcome to my course, Angular HTTP Communication. I'm a server and client-side web developer. Angular is a wildly popular client-side web framework, and for lots of good reasons. It helps you quickly build well-structured, maintainable, and performance-oriented web applications. In this course, we're going to cover both basic and advanced HTTP features available in Angular that help you successfully communicate with your server and efficiently retrieve and manage data in your applications. Some of the major topics that we'll cover include consuming REST services, retrieving data with resolvers, creating interceptors, caching data in your apps, and unit testing your HTTP request. By the end of the course, you'll know how to use all the major features in Angular's HTTP client to retrieve and update data, but also manage that data on the client efficiently so that your app provides a great experience for your users. Before beginning this course, you should be familiar with the basics of Angular and TypeScript, but you certainly don't need to be an expert. I hope you'll join me on this journey to learn about Angular's HTTP client with the Angular HTTP Communication course at Pluralsight. Angular is a framework for building web applications, and there is nothing more fundamental to a web application than the HTTP protocol. Hi, I'm Bryce. In this course, we're going to go beyond the sort of automatic use of HTTP most of us take advantage of as web developers. We know our client-side code, images, and other assets get delivered to the browser over HTTP, and you likely know, if you're watching this, that you can fire off a simple HTTP request in your Angular code to get some data from the server. That's great, but most client-side web apps need lots of data from the server. I'm going to show you how to use the APIs built into Angular to fully harness the power of the HTTP protocol and precisely control how you retrieve and manage all of the data your app needs. Now, I want to be careful to point out exactly which APIs I'll be using in this course. When Angular 2 was first released in September 2016, you made HTTP calls with it by first importing the HTTP module and then using a class simply named HTTP that included methods for making HTTP requests. It worked fine, but the API was a little clunky and it was missing some nice features that developers appreciated in the 1.x version of Angular, now known as AngularJS. So, in version 4.3 of Angular, which was released in July 2017, the Angular team added a completely new set of APIs for making HTTP requests. They're in a module named HTTP Client Module, and the class you use to make requests is named HTTP Client. Beginning with the release of Angular 5 in November 2017, the older HTTP module has been deprecated. So in this course, I will exclusively focus on features available in the newer APIs originally released in version 4.3. Let's now take a closer look at what those features are and how they fit into the remaining modules of the course. After this introductory module, I'll show you how to consume a REST service using the HTTP client. I'll use the HTTP GET, POST, PUT, and DELETE verbs to retrieve and make changes to data on the server. After that, I'll show you some more advanced techniques, including how to encapsulate HTTP details in a service, make requests with a resolver, and properly handle errors. We'll then see how to create interceptors. They allow you to write a bit of code once that can read and modify all HTTP requests and responses. Once we've implemented some basic interceptors, I'll show you how they can be used to build a client-side cache in your app, saving you from making unnecessary calls to the server. In the last module, I'll show you the built-in HTTP client testing module and HTTP testing controller that help you write unit tests for your HTTP request. Let's now go have a look at the demo project I'll be using in the course. In this demo, I'll give you a quick overview of the app I'll be working on in the course and how all of the code in the project is structured. I've named the app Book Tracker, and it may look familiar if you watched a couple of my other courses. It's a very simple app that lets kids keep track of the books they have and how much time they spend reading. This is the main screen in the app, and it's being loaded by an Angular component I named Dashboard. As you can see, it has three main sections. The first lists all of the books in the kids' library. The second lists all of the readers using the app, and the third is a short section that lists the current most popular book. All of the data you see on the screen now is currently hard-coded in the client code. Throughout the course, we're going to change that, and I'll show you simple as well as sophisticated techniques for retrieving it from a server. There's a link at the top of the page for adding a new book. It takes you to a screen where you can enter information about a new book and save your changes. It doesn't work yet, but in the next course module, we'll wire this up to add new books to the server. There's another link at the top for adding new readers. The app title on the left side of the title bar is also a link and takes you back to the dashboard. In addition to the components for adding new books and readers, I've also already got separate components for editing both types of data. Notice that each book has an edit and a delete link that will also wire up to make the appropriate HTTP request to the server. Clicking on an edit link takes you to an edit component that lets you change any of the data about a book and click the Save button. This screen also has a Set as Most Popular button if you wanted to make this particular book the current most popular book in the library. You can see more about how I use a service to manage the most popular book in my earlier Pluralsight course titled Angular Services. The delete links don't take you to a separate screen, but we will update them in the next module to actually send requests to the server and perform delete operations on the books. Data about the readers may also be updated and deleted, much like books. Okay, that's about it for the functionality right now. Let's now jump over to my code editor and see how the project is structured. I'll be using Visual Studio Code as my editor. It works great with TypeScript and Angular, but so do a number of other editors, so use whatever you like. I'm not going to go over every file in my project, but I will say that most of what I have here was created with the Angular command line interface, the CLI. Therefore, it should look reasonably similar to other Angular projects you've seen. There are a handful of additional things here, though. The .vs code folder contains a file with a few settings for my editor. The server folder contains all of the code for a simple Node.js server application. It's a pretty simple application I built with the Express framework that will both serve the compiled Angular app to the browser and provide several API endpoints we'll use in the course to send and receive data to and from the server using HTTP. The data we'll read and write on the server is stored in a couple of text files inside the server folder. There's no fancy database, so I hope that makes it easier for you to get started working with the project yourself. I'll expand the source folder and then the app folder inside it. It contains all of the client-side code. I've got separate folders for each of the Angular components in the app. Each of those folders contains a TypeScript file for the component and an HTML file for the component's view. I've also got a folder named Core where I've stored the files for a shared core module. This module provides some of the Angular services in the app, including the data service here that I'll be using quite extensively in the course. All of the HTTP calls I make to the server will be made from the data service. A little further down is the Models folder. This contains classes for the entities I'll be working with in the app. I'll quickly open the books.ts file, and you can see that it's just a simple TypeScript class containing the properties I'm storing about each book. The Services folder is just a place to store any other Angular services I may decide I need in the app. It currently just has a badge service I wrote to assign a badge to each reader based on how many minutes they've read. I'll scroll down just a little and give you a peek inside the data.ts file. This is the file that contains the hard-coded client-side data currently being used in the app. It exports an array of reader objects named allReaders and an array of books named allBooks. This data is just here to provide some minimum functionality in the app until we start adding our HTTP calls. In the next course module, I'll start updating the app to get data from the server. Let's now take a look inside the package.json file in the project. I'll close the sidebar so we can see it a little better. The primary thing I want to show you in here is the start script inside the script section at the top of the file. This is the script I'll use to build the app and start the Node web server. I'll open the terminal built into Visual Studio Code and show you how I run it. The server is actually already running, so I'll press Ctrl-C to stop it. I can then restart it with the start script above using the command npm start. You can see that it starts the web server listening on port 3000. It then builds the Angular app in watch mode so that any changes I make to the code will automatically trigger a new build. That will make it easy for me to make changes and quickly see them just by refreshing my browser. Once everything is built, I can hop back over to my browser. I change the address to localhost:3000, and you can see that it automatically routes me over to the dashboard component and everything still works like it did before. Okay, before I start writing any new code, I want to take just a minute and talk about how RxJS fits into Angular apps. I'll do that in the next clip. Before I really get into the code, I want to take just a minute and talk about the role RxJS plays when making HTTP requests with Angular. RxJS is a separate JavaScript library for reactive programming with observables. Angular is built to work with and is dependent on RxJS. It even gets installed for you when you create a new app with the Angular CLI. The HTTP client class makes heavy use of observables. They represent a stream of data that may arrive over time. In the case of HTTP requests, that stream is usually just a single HTTP response object. One of the nice things about working with responses as observables is the number of RxJS operators available to help you manipulate the data in the response. Operators are effectively functions that operate on the data in an observable, and they also return an observable so they can be chained together. I want to point out that I will absolutely be using RxJS in the course, but I'm not going to dive very deep into all of its features. I'll explain the features I'm using, but if you want to really understand all it has to offer, I've got an entire course titled RxJS Getting Started that will teach you everything you need to know about it. Let's now jump into another demo and get the data service in the app ready to make HTTP requests. In this demo, I'm going to show you how to import the HTTP client module and inject the HTTP client into an Angular service so that your app is ready to make HTTP requests. Before I show you how to get the app ready to make HTTP requests, I want to use the Angular documentation to make it clear which HTTP client I'll be using. I'm here on the official Angular homepage at angular.io. I'll click the Docs link at the top of the page and then click the API link from the menu on the left. From here you can filter or search for lots of different items available in the API. I'm going to use the filter box and search for the string HTTP. The first two sections that show results contain all of the newer HTTP APIs that were added in version 4.3. These are what I'll be working with in this course. They are the items in common/HTTP and common/HTTP/testing. Below that are two more sections, HTTP and HTTP/testing. Those sections contain the deprecated HTTP APIs. Okay, I'll now jump over to my editor and get the app ready to make HTTP requests. I'm going to start in the app.module.ts file. This is where I'll import the new HTTP client module. I'll add an import statement at the top of the file to import HTTP client module from @angular/common/HTTP. I'll then scroll down to the ng module decorator and add the HTTP client module to the list of modules in the imports array on the decorator. This effectively makes the module available everywhere in the app. I'm going to make all of my HTTP requests from inside the data service I've already created, so I'll open it next. It's inside the core folder in the project. Since I already imported the HTTP client module, the only thing I need to import here is the HTTP client class. It's also found in the Angular/common/HTTP module. That makes the class available in this file, but to get an actual instance of it I can use to make requests, I need to inject one into the service's constructor. I'll do that by adding a parameter to the constructor. I'll name it HTTP and specify its type to be the HTTP client class I just imported. By including the private keyword in front of the parameter declaration, I can now use the parameter as a private class member throughout the class. To quickly demonstrate that, I'll jump down inside the getAllReaders method and reference the new member by typing this.http. I'll type another dot, and you can see I'm now getting code completion help showing me the methods that exist on the HTTP client. We'll start to use some of these in the next module to make requests to the server. I'll delete this for now. As I mentioned earlier, many of the methods on the HTTP client return observables, and observables are part of the RxJS library. So that I can work with those observables in this file, I'm going to add another import statement at the top that imports observable from RxJS. Okay, you've now seen how to import the HTTP client module and inject the HTTP client into an Angular service. That's really everything we need to get started using the newer HTTP APIs. In the next module,